Welcome to lesson number 4. We're going to look at solving logarithmic equations. And today we're going to look at two new laws that will help us solve these equations. The first one we're going to look at is if we have log b of p, and that's equal to log b of q. So in this case, the bases of my logs are the same. Now what we can do is we can get rid of those logs and we can just say that p is equal to q. And another law we're going to look at using is log b of p is equal to q, in which case you already know this, but you can just rearrange this into exponential form in order to solve those expressions. We're going to skip over the exploration and just go into example number 1. So when we're looking at these log laws and looking at using them, what's going to happen is we're going to get in cases where, just like when we were working with factoring and polynomials, we got into cases where we had extraneous solutions. And so in those cases, there was only one value of x that was an actual solution, because what happened was when we were working with extraneous solutions in pre-calculus 11 was we ended up with something that could have been the square root of a negative number, which we couldn't have. And so now what we're going to be looking at is we're going to have a negative value as our base in our log, which we can't have, or a negative value that is the argument in our log. And so let's look at when this occurs and what we need to do when or if it does. So log x squared is equal to log 16. And so if we look at the previous law that we were looking at, then we could say that we drop those logs and just say that x squared is equal to 16. Now if I wanted to solve for x, then I would come up with two values. X could either be 4 or it could be negative 4. So I could say plus or minus 4. Because if I take this square, or if I square negative 4 times negative 4, I'll get 16. If I square 4 times 4, I get 16 as well. So now all we need to do is verify which one is the actual solution. And so if I'm verifying x equals 4, I know that the left side needs to be equal to log of 4 squared, and that would be equal to log of 16. Now let's see the left side, or sorry, the right side. X equals negative 4. For the right side, I'm going to have log of negative 4 squared, and this is going to equal log 16 as well. And so in this situation, both of these solutions are okay. Both of them will work out. X is equal to plus and negative 4. Because my left side and my right side are equal. But let's see what happens in this second situation over here. So 2 log x is equal to log 16. I'm going to use my power law in order to bring this coefficient up. I'm going to get x squared. So log x squared is equal to log 16. And again, I'm going to get x squared is equal to 16, where x is equal to plus or minus 4. All right, let's look at my left side now. I'm going to get 2 log 4, and that is equal to log 4 squared. And that is equal to log 16. And that equals the right side, log 16. Now let's verify the other solution, where we're going to verify negative 4. So 2 log times negative 4. And if you were to plug that into your calculator, you're going to get this as your solution. It's a non-real answer. And so that tells us that it's not possible. So in this situation, x is only equal to positive 4. not -4. So there's going to be situations where we do need to verify whether or not it's a suitable answer. Now let's look at what happens on the graphing calculator if we were to graph either one of these. Well, actually, we're going to graph both of them. Now, for this first one, we had log x squared equals log 16, but I'm going to rearrange this so instead I'm just going to be solving for 0 here, or my y, and I'm going to have log x squared minus log 16. So all I did was I brought the 16 to the other side, log 16 to the other side, and that's what I'm going to graph. So log x squared minus log 16, graph. Oh, and I need to fix a mistake. I put it outside the brackets. There we go, this is better. Okay, so just like we solved earlier, what we're looking at is our values of x here, so our zeros. And I'm crossing at -4 and +4. And if I wanted, I could zoom in on my calculator functions and show you where that actually is. But just for the sake of time, I'm not going to go into all of that. But we're at crossing at -4 and +4, just like we determined up above. Now let's look at our other solution. So instead of graphing 2 log x is equal to log 16, I'm going to bring this log 16 to the other side, and I'm going to be solving for y, so I'm going to have 2 log x minus log 16. So 2 log x minus log 16, and there's only one solution on that graph where it's crossing at +4. Now, for the last section, explain why the solutions to the log equations are not the same, even though 2 log x can be written as log x squared. Well, they have different domains, right? Like 2 log x, this domain is going to be x has to be greater than 0. So this value of x had to be greater than 0. And for this one here, my domain would be x has to be, or it can't be, equal to 0, right? If I had a value of x equal to 0, then it wouldn't work. So it has to be any value other than 0. It could be a negative value, it could be a positive value. But with 2 log x, it had to be greater than 0. Now let's look at some situation where we'll have to solve for x, just like we were doing last time. And what we're going to be doing here is using our log laws in order to solve these equations. All right, so first one here, log 4 of x plus 1 minus log 4 of 2x minus 3 is equal to log 4 of 8. Now notice that we have all the same bases, but before we do anything with these bases, we're going to use our log laws. So, and what I mean before we do anything with the bases, before we get rid of these actual log 4s, we're going to simplify this, and so we're only solving for these values of x. So the first thing I'm going to do is use my quotient law, where I have x plus 1 divided by 2x minus 3, and I know to do that because of that subtraction sign that indicates to use the quotient law. Now what I can do, since it's simplified, is now I can get rid of my log 4s. And so I'm going to be left with x plus 1 is equal to 2x minus 3, and that is going to be equal to 8. Now if I solve this, I'll be left with x plus 1 is equal to 8 times 2x minus 3 if I get this off from the bottom, and we'll have x plus 1 is equal to 16x minus 24. If I add my like terms together, I'll bring x to this side, so I'll subtract x's from both sides, and I'll be left with 15x. If I bring 24 over this side, I'm adding 24 plus 1, I'll be left with 25. And if I solve for x, x is equal to 25 over 15, or if I reduce that, 5 over 3. And now we need to verify this solution. So the next thing we're going to do is put this 5/3 into the top, into what we started with, and you're going to get a value. And I'm going to skip that part, but we're going to get the same value. It's going to work out where the left side is going to equal the right side. And so our actual answer here is 5/3. Now let's look at this next problem. Log 6 of x plus 4 is equal to 1 minus log 6 of x plus 3. Now the first thing we need to do is rearrange this so it's a little easier to work with. And so to rearrange this, what we're going to need to do is put our log to the other side. So we're going to end up with log 6 of x plus 4 plus log 6 of x plus 3, and that is equal to 1. Now what I can do is I can use my product law where I'm going to have log 6 of x plus 4 times x plus 3 is equal to 1. What I'm going to be left with is a polynomial. And remember, now I can rearrange this into exponential form. So I'll have my argument, my base, to the power of 1. So I'll rewrite this as, so x squared plus 3x plus 4x plus 7x plus 12 is equal to 6 to the power of 1. So remember, the base becomes the base for my exponent, and this, which is my y, becomes my exponent. And so now what I'm left with is x squared plus 7x plus 12 is equal to 6 to the power of 1, or just 6. Now what I need to do is get the 6 to the other side, set this equal to 0, x squared plus 7x plus 6. If I bring this 6 to the other side, and that's equal to 0. And you probably thought you were done with factoring, but unfortunately you are not. And yeah, so we're going to have to factor this. So remember, what values are going to multiply give you 6 and add to give you 7? Well, if I have 1 and 6, x plus 1 times x plus 6 is equal to 0. And so your values of x here are going to be x is equal to -1 or x is equal to -6. Now that we have two values of x, we are going to have to verify. So first thing, let's verify x is equal to -1. And then we'll verify x is equal to -6. All right, so let's do the -1 first. So I have log 6 of -1 plus 4 is equal to 1 minus log 6 of -1 plus 3. And I get log 6 of 3 is equal to 1 minus log 6 of 2. And let's see if these are equal terms. So log 3 divided by log 6. I get 0.61, and then I'm going to have log 2 divided by log 6, and 1 minus. So they are equal terms. So my left side equals my right side. Now let's see the other side. I have log 6 of -6 plus 4 is equal to 1 minus log 6 of -6 plus 3. Well, what we're going to have here are two negative arguments, and we can't have a negative argument, right? So we have log 6 of -2 is equal to 1 minus log 6 of -3. And so right away, I don't even have to calculate this because I know that I can't have negative arguments. So I'm going to say not possible, and then that tells us that x is equal to -1, not -6. All right, with this next question, what you need to do is exact same thing we were doing. I would recommend bringing this coefficient up as an exponent and then solving. And what you're going to get is, again, a polynomial like we ended up over here, what we ended up with over here. And it's going to be one that you can't factor. And so if that happens, then you have to use your quadratic equation, right? And yeah, it's not difficult by any means, but it's just going to be an extra step. All right, let's look at this next problem. Solve the equation log 2 of log x, 3x plus 4 is equal to 1. And by doing that, we need to convert it to exponential form twice. And it says it's reminding us to check for extraneous solutions, and so hint, hint, there's probably going to be one. All right, let's start with our expression. Log 2 of log x of 3x plus 4 is equal to 1. So they want us to solve by converting twice exponential form. So let's do that the first time by getting rid of this log 2. And we know that log 2 of this log is going to equal 1. And so we could rearrange this by saying log x of 3x plus 4 is equal to 2, which becomes my base, and 1 becomes the exponent. And 2 to the 1 can just be written as 2. We don't have to write this as 2 to the 1. Now what I can do is I can say that, and remember another thing they want us to do is do it twice. And so now I have log x is equal to 2. So if I get rid of this log x, I have 3x plus 4, and x becomes the base, and 2 becomes the exponent. Since it was 2 to the power of 1, it's just going to be 2 left over. Now I have 3x plus 4 is equal to x squared. Now if I make this a polynomial, I'm going to have 0 on this side. I'm going to subtract this whole term and bring it over here. So I'll be left with x squared minus 3x minus 4. And this is something that it looks like it's factorable. So if I have two numbers that multiply to give me -4 and add to give me -3, that's probably going to be -4 and +1. And so that tells me that x is equal to +4 or x is equal to -1. And now we got to check for our extraneous roots. Now let's verify the first one. So verify x is equal to 4, and then we'll also verify that x is equal to -1 and see which one or either or neither works. All right, so we know that it has to equal 1, right? So let's see, log 2 of log 4 of 3x is 12 plus 4 is 16 is equal to 1. All right, if I have log 4 of 16, well, actually, a better way to go about this is to break it down a little bit, right? Like if I have log 4 of 16, well, we'll just solve the inside first. Log 16 divided by, it's going to be 2, but you could plug that in your calculator first and then simplify it that way, or you can just go through the steps of saying, okay, well, what squared is equal to what? 4 to the power of what is equal to 16, and you'll get 2. And log 2 of 2 is equal to 1. We know that if I have a base and an argument that are same, it is just equal to 1. And so therefore it works. Now let's look at the left side, or the right side. Log 2 of log -1 times 3 -1 plus 4 is equal to 1. Well, -3 plus 4 I'm left with 1, but I have this negative root, so, or this negative base, and it's not going to be possible to solve. All right, let's look at the last few examples here. And I'm just going to look at this one and the other, and we won't look at the bottom solution or the bottom example at all, just for the sake of time. All right, so solve the equation log x squared minus 3 times log x is equal to 10 by using the laws of logarithms. All right, so one way we can do this is we can rearrange this, so we could bring this back up, and we would be left with log x squared minus log x cubed is equal to 10. And then I can use my laws of logarithms, which would leave me with log x squared divided by log x cubed is equal to 10. Then what I would be left with is log x to the negative 1 is equal to 10. And then if I bring this negative 1 down, I'll be left with negative 1 log x is equal to 10. The last thing I need to do is, we don't want to be working with negative laws, so negative logs, I'll divide both sides by negative 1, which would leave me with log x is equal to negative 10. And now I can solve for x by converting. So remember, this is base 10, so this is going to become x is equal to 10 to the negative 10, which is equal to, if I express this as a positive exponent, 10 to the positive 10. Now explain why the equations log x squared minus 3 log x equals 10 cannot be solved using the laws of logarithms. Well, if we look at these two solutions, just like we look at example 1, these aren't the same. So log x squared is not the same, doesn't equal log x squared. So what's going to happen is we're going to end up with negative numbers here that we can't solve because we can't equal 0 here. And yeah, if you are having difficulties with these two, if you want to solve those, I'd be glad to help you in class, but I'll just leave the video for here for now.